episode of the Millikan oil drop experiment 2. A 4.9 times 10 to the minus 15 kilogram oil drop hangs between two parallel plates. A. Calculate the oil drop's charge, and B. Calculate the electron excess or deficit on the drop. So in this problem, we're actually given a diagram of what's happening. In video 166, yesterday's video, we weren't given the picture. We were given a little bit different information in the problem, and we had to come up with this strategy on our own. So if you want another problem to practice this with, be sure to check out video 166. This video looks at it through a different lens. So since we're given the picture, so we can see the negative plate is on the top, positive is on the bottom. Let's start with the obvious. Okay, we know that the the oil droplet is going to have a weight, and that weight Fg is going to be going down. At the same time, though, if it's just going down, if my electric force also goes down, well, this oil droplet's going to want to go down. But the oil drop hangs between two plates, or as in the previous question, it was suspended. It's the same idea. It's not moving. That means there has to be another force going in the opposite direction with the same magnitude to counteract it so it doesn't move. And in this case, it's going to be the electric force that goes in the other direction. So based on this, I can see that my net force in the y direction is 0. So let's let up be my positive y direction. F net y is 0. And based on our picture here, I've got my electric force and my force of gravity in the y direction. Notice that I left the vector symbols on top, and that's because I did not assign a direction yet. I'm just adding the vectors. I'm going to assign a direction in the next step. Now, according to this picture, Fe is going up, Fg is going down, Fe minus Fg is 0. Bring the Fg to the right, Fe equals Fg. Now, before I go any further, it's come to my attention that we actually haven't discussed what sign the charge is going to be, and that's actually the first thing we did in video 166. So let's actually take a look at this for a moment. We justified that the electric force is going up because it has to counteract gravity going down, its weight. So if the electric force is going up, that means whatever this is attracted to a negative plate. And it's certainly not going to be a negative charge here because negative is not attracted to negative. Positive is attracted to negative. Therefore, the charge must be a positive charge. Okay, anyways, let's continue. So we said Fe is equal to Fg. Electric force is given by the product of charge and electric field, and Fg is just mg. Now, as stated in the previous video, the electric field between two parallel plates separated a distance delta d apart with a potential difference of delta v between them is given by, so we have our Q. My electric field is given by delta v over delta d equals mg. Okay, now I'm solving for charge here. I have to calculate the oil drop's charge. So Q is equal to mg times delta d divided by delta v. So we arrive at the same formula. So I'm just going to start plugging in my values now. So Q equals, now the mass here is different, 4.9 times 10 to the minus 15 kilograms. My G is the same as always, 9.8 newtons per kilogram. The distance between the plates, in the previous problem we were given it in millimeters, here it's centimeters. Now remember, to go from centimeters to meters, you divide by 100 or you multiply by 10 to the minus 2. Okay? And we divide all that by the potential difference, 210 volts. So punch those numbers in your calculator and you should get a charge of 4.6 times 10 to the minus 19 coulombs. Now we don't have to do anything else at this point because, well, our charge is positive. So that's the answer for part A. For part B, we have to calculate the electron excess or deficit on the drop. So like I was mentioning in the previous video, most objects are neutral or close to neutral because even though they're made up of billions and billions of positive and negative charges, most of these cancel out. So when there's extra charge, well, it has to come from either having gained electrons or lost them. Now, since my net charge is positive, that means I lost electrons. So I lost some of my negative charge. I have more positive charge left over. So that means I have a deficit of electrons. Now, how many electrons? Well, this is the total charge, net charge now. So if I want to figure out how many electrons, N, I just have to take the total charge that there is and divide by the charge of one electron, right? That's going to tell me how many pieces I have. So 4.6 times 10 to the minus 19 coulombs divided by 1.602 times 10 to the minus 19 coulombs. Okay, so let's grab our calculator and crunch that out. Notice that the times 10 to the 19 is just going to cancel. So all you really have to do is 4.6 divided by 1.602. 2.87 electrons. Okay, now here's the thing. You can't have 0.87 of an electron, unfortunately. Now, normally in math, we take that number and we round it up to 3. But if you have 0.87 of an electron, it's not the same as having a whole electron. So actually, we have to round this down to 2. So in fact, we have a deficit of 2 electrons. If this number was something like 3.00001, you can say it's 3 electrons. But like this, you can't say that there's 3. You have to round down and say there's 2. Okay, guys, so that's it for this video. I hope you enjoyed it. Be sure to smash that like button if you did, and subscribe to Physics in the Flesh. I post every weekday at 12 noon, and if you hit that little bell icon next to the subscribe button, you can be notified every time I post a new video. Okay, guys, that's it for today. Enjoy your weekend, and I will catch you next week on Monday at 12 noon for video 168. Alright guys, that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button so I know what I'm doing makes sense to you guys. And you know how you can stay tuned for my latest videos? By subscribing to Physics in the Flesh. I post every weekday at 12 noon, and this way you guys can always be the first to know when I post a new video. As always, guys, thank you so much for watching. If you missed any of my earlier videos, be sure to click over there on the right. You can click and watch those videos on your screen right now. Anyways, guys, Physics in the Flesh out. Whoop, whoop. Holy crap, my nose looks big on camera. I gotta find a new angle.